Hello students, in this video we'll discuss about LR parsers, especially the steps in construction and parsing. So previously we have discussed about bottom-up parsing. So LR parser is also one type of bottom-up parser. So first of all, whatever the parser we are taking, the intention of every parser, right, to check whether the input string is syntactically correct or not. So in operate presidency parser also, first we have constructed the table, then we have taken a string and approved it how to check whether it is accepted or not. Same way, in LR parse also, first we have to construct the table for the grammar. Like in LL1 we have constructed the table. In operate presence we have constructed the relational table. Same way in LR parser we have to construct the parsing table. And once the table is constructed with the two sections, action and go to, right? So here we are going to perform in action table shift reduce. That's the reason we call these parsers are shift reduce parsers, SR parsers. Then other than that, we are going to perform two more, accept and error. So then first let me explain how a string is parsed or check whether it is accepted or not from the predefined table. So we'll discuss how the table is going to be constructed later, this one. But I'm assuming that the table is already constructed. Then I'm going to explain how, if a string is given to you, how to check whether the string is accepted or not from this grammar, where the grammar is represented as LR table, right? So for a given grammar, how to construct this table, that we'll discuss later. So the algorithm is, if it is, right, if action is S, shift action, then we have to push A of I and also S, the number whatever we have. And we have to read the next input symbol. And if it is reduce, we have to pop up the symbols which is 2 into right hand side. Like if we are having 3 symbols, we have to pop up 2 into 3, that is nothing but 6 symbols. So if the action of SM comma AI is accept then stop, if it is error then we can say that it is a syntactic error. Of course you might be having some doubts here, let me explain with the example. See guys, initially the stack, right, the model here, this is a stack. Initially it is going to have 0, okay, and the input symbol we are having and the table. So three things, let me just go through with this. See, the stack is having 0 and input is id plus id star id plus id dollar. Then you have to take it from this table. Let me explain the same thing, right? See, first, so 0 and the input is id. So what is a 0 id? So we are having S5. So shift to 5. So what you have to do, first we have to shift the input symbol, then we have to push the 5, then we have to go to the next symbol. That's what we have discussed. So push the input symbol, then push the value whatever we have and advance the input, right? So same way, then what is the top of the stack now? 5, and the input symbol is star. What is a 5 star? 5 star is R6, reduce. So reduce means we have to replace this, right? Go and by removing the number of production. So here, so we have removed the 2 id and 5 and we have pushed the 3 because here we are having go to of 3 in the table. So then we have taken this R6, right? Then what will be happened here? Next 3 star. What is a 3 star here? Again it is R4. So if it is R4, again reduce 4 and go to 2. So we are removing it and taking the 2 here. So now 2 star. What is a 2 star? S7. So if it is S7, you have to shift star then 7. So what will be happen? Star and 7. Now 7 ID. So what is a 7 ID? Again shift to 5. So you can take shift 5 means again push the ID and 5. Then 5 plus. So 5 plus means R6. Then reduce. We have to remove the 2 into length of right hand side and we have to go to the second state here. So same thing, you'll get 0t. So 2. Then 2 plus. Again 2 plus means reduce. So remove the length of the right hand side production and push the 2 and go to 1. So you're going to have 0 E1. So in that way, you have to continue this until you'll get the 0 E1. That is nothing but accept $1, right? So simple logic guys. If it is a shift action, push the input symbol and the number. If it is a reduce, just pop the length of the right hand side productions and apply the go to operation, whatever we have, right? So of course we'll discuss this again with a example, the table how we have constructed here, right? So then let me go with this construction, guys. Here in construction we are having mainly 4 steps. First we have to take the augmented grammar. So that is same for all the LR parsers. If it is LR0 or SLR1 or CLR1 or LALR1, so the steps are same, guys, right? So first step. Second one, we have to create canonical LR0 or LR1 items. See, for these two parsers, we have to construct LR0 items. That's what we have taken in the last video. And for these two parsers, we have to construct LR1 items, where we are going to use two techniques, closure of I and go to of I, comma x. So these two are going to be different for LR0 items and LR1 items. How they are, we'll discuss, right? So once you got the items, right, they are denoted with the I0, I1, so on, IN. So once we got the items, then we have to construct the DFA of these items. So once we got the DFA, then it is easy to construct the table, where the table is going to have 3 sections. One is states, another one is action part, and another one is go to part. So in action part, we are going to perform only 4 actions: shift, reduce, accept, and error, that we have already discussed, right? Accept and error. In go to, we have to just write down the numbers. That's it. So that's what we have discussed here, guys. See, for a given grammar, how to construct it, that we'll discuss. Don't worry about that. Okay. So if you have any doubts in parsing also, once we have done with the table, then all your doubts will be clarified. So let me just go with this. Step 1. Okay, once I'm repeating it, all these steps are same: table, draw, only go to, closure, and different. And what are the difference in each and every parser? Of course we have some difference that we'll discuss, right? So first step, take augmented grammar. Guys, if you are given a grammar and you're asked to construct the LR parsing table, the first and foremost step is take augmented grammar. It's very easy, guys. Just take all the productions as it is and take the new non-terminal which is deriving the starting symbol. That is called augmented production. What is the use of it? To accept the grammar, then we need an augmented production. Here we have written accept, right? So this accept is based on the augmented grammar only. So if there is no augmented production, that is difficult to write it. There's a reason. First you have to add the augmented production. What is the use that I told you? Then the second step is we have to create the LR0 item sets for the first two parsers and LR1 item sets for the second two parsers. So if a production is having like this, A tends to XYZ, the possibilities are you have to keep the dot before. The dot indicates how far the right hand side production is scanned, right? The symbol before the dot is nothing but the last symbol we have scanned. The symbol after the dot is nothing but the next symbol to be scanned. Here last symbol nothing, but here last symbol is X, next symbol is Y. Last symbol is Y, next symbol is Z. Last symbol was Z, we have scanned recently and there is no symbol. Then we can call such symbols are complete productions, or we can perform reduce action for this. Reduce or accept. And when your dot is not at the end of the production, we can call it as incomplete, right? For this, we can perform either shift or go to. For this, reduce or accept. That's it. So if the dot is at the end, then only we perform the reduce. If the dot is in middle of it, either we have to perform shift or go to. What you can find here. See, this is reduce, shift, this is go to. So when reduce, if the production is completed, shift incomplete or go to, right? So then epsilon means it's a treated as complete production only. In LR1 items, we should have lookout symbol for each and every production. Same, the dot denotes how far it is scanned, the symbol before the dot is last symbol what you have scanned next, but every production should have a look ahead symbol. Again same, this is a complete production, reduce or shift, accept. These three are incomplete, shift or go to. Everything is same, but you have to find the locate symbol. How we have to do it, that we'll discuss while we are doing the L, right? So then here we are going to use the two techniques. One is closure and go to. So closure is nothing but just you have to find the augmented production. So if your grammar is like this, then we have to add the augmented production. So E dash tends to dot E. Then first to get the I naught, we have to find the closure of augmented production. So what is augmented production for this grammar? E dash tends to dot E. So if the symbol immediately after the dot is a non-terminal, then again add all the productions of this non-terminal with dot at the beginning. That's what we have done. That's it. Closure means if it is a non-terminal immediately after the dot, add all the productions of that non-terminal with dot at the beginning. Again, E, add all the productions of E with dot at the beginning, already there. And T, add all the productions of this T from the grammar with dot at the beginning. So you got T tends to dot T star F, T tends to dot F. Again F. So if it is F, add all the productions of F with dot at the beginning. That's it. ID, no symbol. So like you have to do an iterative approach. So what is closure? Augmented production you have to take. If it is a non-terminal, add all the productions of that non-terminal with dot at the beginning. Like you have to repeat it until there are no production to be added. Same way, go to. See, go to means for every locate next symbol to be scanned, you have to apply the go to. Means this is assume that I. Then you have to write go to of I comma E. Go to of I comma E, go to of I comma T, go to of I comma F, go to of I comma open parenthesis, like that you have to write. What will be happen means, so go to of I comma E means wherever you are having the dot before E, you have to move it after E. Wherever you are having the before E, you have to move it. See, E dot plus E. After moving again you have to apply the closure. If it is a terminal, leave it. If it is a non-terminal, again you have to add the productions. For example, let me write here go to of I comma open parenthesis. So move the dot from here to here. So F tends to dot E. Again non-terminal, add all the E productions. E tends to dot E plus T and E tends to dot T. Again T. So you add T tends to dot T plus E, like that you have to add it. T star F and T tends to F. So dot F and again F tends to dot ID, like. So once the dot is moved, closure go to is applied, again you have to check whether it is a non-terminal or not. If it is a non-terminal, you have to add it, like that. You have to write go to of I comma E, go to of I comma T, go to of I comma F. Every go to will give you a new or existed states. So assume that we got some states from it. So once we got the states, so on go to, if I read, see where we are going, I1, like you have to draw the DFA of these states. So how we got it, that we'll discuss. Just DFA, remember it. So for every go to, you have to write the new state that are existing, you have to represent that. So how to draw this, that we'll discuss while we are discussing about the grammars, right? Construction. Just I'm telling that you have to, once you got all the items, you have to draw the DFA, right? So based on this DFA, you can construct the table. See how we got all these items, guys. I'll tell you in the next video, right? So construction. Now once we got the DFA like this, see I1, I2, I just represented as diagram. Then how many states we got total? 0 to 5, take the rows, and action part terminals plus dollar, go to part non-terminals. So in 0C, go to, just write down the number. 0A, write down the number. If it is a terminal, write down the shift, like 0A S3, just write down terminal means S3. 2A S5, 2A S5, like that. If it is a non-terminal, simply write it. If it is a terminal, write down the S. So when we have to perform reduce, guys, if a production is completed like this in I4, you have to perform the reduce. In I5, the production is completed, then you have to perform the reduce. So here we don't have any complete production, that's why I didn't perform reduce here. And I1 also no reduce, because it is augmented, that's why we have to perform the accept, not reduce. I2 no complete, I3 complete, reduce. So if augmented production is completed, perform accept. If normal productions are completed, perform reduce. So all we will discuss with an example. Don't worry if you have some doubts in this. Just remember the steps. Okay. So in the next video, I'll take an example and I'll explain it.